We can just start. All right, welcome everybody. Good to see you. Maybe just to set up a little bit for the lecture tonight, and then a quick bio. But I think we've worked hard this semester to pull in different people that support different degrees within the college. And so tonight we're going to be talking about urban issues, and we have an urban design program, but we're also a school that values practice and technology. And so it's a really exciting thing to have someone here who's going to talk about technology as it relates to urban design. And as we often like to do with these lectures, I think it's also an opportunity to promote some of the new certificates that we're thinking about in public interest design and GIS. Geographic Information Systems. And so I think some of what we're going to hear tonight is related to some of these things. So it's really exciting to be able to have Rebecca here with us tonight. Rebecca Lynn Cooper brings technical knowledge, professional experience, and historical understanding to the task of building better cities. She's future-focused, evidence-based, data-oriented, and deeply passionate about exploring the constellation of factors and forces that shape public space. She earned her professional degree in architecture from the Boston Architectural Center. We were also trying to figure out if we overlapped at all when we were in Boston there, but I don't think we did. But after she finished at the BAC, she earned her master's from Harvard. She studied and taught architectural and urban design history and theory in Boston, Paris, and LA. Conducted scholarly research into the production, perception, and inhabitation of built space, and guided the research and writing efforts of design students at the graduate and undergraduate level. At Dassault, 3D Experience City team, she serves as a strategist and subject matter expert on the trends, challenges, and business processes of the urban planning and design disciplines. And I should also mention that Dassault is a name that everyone should know. They've been a longtime partner with us in the transportation design program, and Dassault was named the industry sponsor, industry partner of the year last year. And so I think that also starts some of the conversations that we've been having. She works with clients from university researchers to elected officials to help calibrate technical tools and software products to assist in their work addressing mobility, environmental and energy challenges in urban and city-scaled contexts. She's joining us from Somerville and Boston, but I think it's also worth noting that she also serves on Somerville's city planning board. So she's involved in technology, she's involved in design, and she's also very interested in issues related to policy. She's going to talk about how all three of those things probably come together.
Sometimes catastrophically.
So please welcome Rebecca.
I promise it's going to be a lot more fun than that bio makes it sound, or at least I hope. In Boston, we have a lot of opportunities where we've seen things go like terribly wrong, and sometimes it's the most fun that we can have to talk about those times. So I want to thank Dean Dobbin and the faculty for inviting me here. It's a real treat to get to see some of what you guys have been images do in our brains, how we receive images, how we think about what we're looking, and then how we use images that we make to reflect how we think about space. So I started, when I started, I was looking both at filmic representation and also at neurobiology. So I was starting to really think about how, when you're getting images this size, I'm sorry about the wire. When you're getting images this size, we start thinking about them not as images, but as spaces. So whenever you guys go to see a film, your brains are reacting to them as if you were actually inhabiting space. And that, when I learned that, that was one of the most exciting things that I discovered. And that's what led me to the practice of architecture and studying design. And I brought the interest with me so that I could keep thinking about those relationships between how we think about space, how that affects the images we make, how the images we make affect how we understand, inhabit, and further think about space. And this is really nothing new. This is the kind of thing that we've been doing ever since we've been making depictions of space. We have representations from some of the earliest ones we have. If you're familiar with the Noli map of Rome, this is one of the first depictions that we had. Where we really started thinking about what it meant to have representations of space as opposed to representations of buildings. I know for architects, you tend to pay attention to the buildings, but when we started thinking about what was important about space, we had the Noli plan, we had Camilo Sitte, where they started trying to create images that got us to think less about form and more about space, which as urban planners we have to think about. It's harder to see, but we have to think about them. They can be really tricky because what we draw, what we make, the images we create, the way we choose to make them, tells us a lot, sometimes without even thinking about it, about how we understand what space is and what space is doing for us. And I kept going back and forth between the idea of film, between the idea of the stories we tell and the images we make, and how those connect or don't connect, as the case may be. And it's important because the stories we tell can often be really compelling, but they're not always true. And the stories that are true and important aren't always compelling. So the challenge, especially if you work in direct contact with the public, is to figure out how to make stories that are both true and compelling. And it's particularly tricky when we start talking about the city. So as I mentioned, I'm from Boston, and I'm not sure how many of you have had the opportunity to look at the city of Boston or Boston urbanism, but when, and they'll kick me out if this gets out that I'm talking about this, but when we in Boston look at a map like this, we have a kind of envy because the logic of this is pretty clear. The representation here is pretty clear. You can think very, very simply about what this space is going to be like. And as an exercise, I want you to think about how you tell somebody to navigate through this space. What kind of story would you tell to go along with this image? What kind of image do you make in order to be able to navigate through a space like this? Because when we look at it, ask yourself the same question for this map. This is Boston. And in Boston, we're known for being pretty peculiar. And we're usually comfortable with being peculiar, but even this doesn't make sense to most Bostonians. And when you work in planning in the city of Boston, eventually when people find out you work in planning, people are gonna sidle up to you. And they're gonna say, you know, there's this thing I've always wanted to know. Why the heck does the city of Boston, why do the streets look like this? Because when you think about how to tell somebody to get from one place to another in a city map like this, you know, you talk, well, in Boston we also talk about you go down this street and then you turn where the Citgo sign is, and then you make another turn where the gas station used to be, which is really helpful. And it's a really complex story, and one of the things that happens is that because people look at the city of Boston, they think, well, why would you make something like that? Why would you make something that looks like that? And people are looking around for a story. because that knowledge is there, that knowledge is underneath what we've made, but it's not really clearly evident. And so people like to tell a really famous story. I don't know if you've heard this story. You're smiling the way you think maybe you have. People always tell a story about the way that Boston developed, and it's down to these guys. Not these guys specifically, but cows in general. Everybody always tells this great story about Boston that the people in Boston are farmers, and when they moved in, they would have their cows, and their cows would march along. And the story would go that every day they would herd their cows off to the market, they would herd their cows off to the meadow to graze, and over time, because cows' hooves would build up a lot of dust, over time they would wear a path through the grass. And then eventually what you do, you just pave over the grass, and that's how the city of Boston gets its form. And it's a great story, right? I mean, it's fun. I bet you'll never forget the story of Boston now. It's got everything, really. It's got a lot of detail. It's rich in detail. It's evocative. It's the kind of thing that sticks with you, and everybody loves to tell that story. But the problem is that not a bit of it's true. So, this map, this simple representation holds a lot of knowledge underneath it, a lot of choices that aren't clear in this map, a lot of history that underlays all this geography. And one of the things you start to learn is that when Boston was first settled, you can see the black outline. That was the landmass of Boston when it was first settled. That was what it looked like when people first arrived here. And the city of Boston as we know it now, wow, I'm sorry about the resolution. The city of Boston as we know it now came about over time. It was literally built from the ground up. Most of the city of Boston was built by trucking in land from other places, by cutting down the hills of Boston and filling in the landscape so that we could have the city that you saw today. And it happened over an enormous amount of time. And all of this is really interesting knowledge. It's when you think about the original condition of the city of Boston, and you think about this, it starts to make a little bit of sense because, you're okay? Because you start thinking about the fact that, you had this piece of land that was the first causeway. So when you think about that roadway, everything is oriented off of this piece of land. And then as different things started to fill in, as they created new neighborhoods, they started moving things around, reorienting streets so that each one of those new neighborhoods had its own expression. Each one of those new neighborhoods had its own presence. And that's why you get something that looks like this. So now when you look at this, now you have all that knowledge. You know it, so you can see it. You can see that this is where the roads, the very first roads through the city of Boston was. And you can see how the pieces filled out, and as each one of those pieces filled in, they started getting their own presence. They started having an internal logic to the planning that related to how they were positioned within the mosaic of that whole. But that's not such a charming story, is it? It's not as great as the cows, right? It's not as memorable. And that's really one of the keys, is the memory is one of the most important things that we have to think about when we make our stories, when we make our images, because this is true, it's not so compelling, and there's a lot of information that's buried in this, that it takes time and space and effort to unpack. So now I have another story to tell you about why it's important that we accurately think about what we're making and about how we're representing what we're making. Now the new owners would prefer that I talk about this as 200 Clarendon Street, but this is a building that's called the Hancock Tower. I don't know if anyone's ever heard of it. Oh, okay, good. So this, at the time, was going to be one of the really preeminent pieces of architecture in the city of Boston. It was one of the tallest buildings that was going to be built in the Back Bay. And it was proposed as a 60-story, like 208 or 780-foot tower, wrapped in glass, built for the John Hancock Company. And the whole theory when IMPE started to work on that, was that because when John Hancock signed the Declaration of Independence, his signature was really big. It was the one you really saw. They thought that what they needed was a really big building that would be a really big presence on the landscape. There we go. So they picked the part of the city that they were going to build it, and they picked the Back Bay. They proposed this lovely building. They hired Henry Cobb of IMPay to do the design. They hired world-class engineers to work on it. They didn't hire anybody who worked in the city of Boston. Nobody on the entire team. Which is a problem because if you live in Boston, if you're from Boston, you don't forget that the Back Bay used to be a swamp. You don't forget that the Back Bay used to be underwater, that it's literally manufactured ground. If you're an architect who works in the Back Bay, you knew just how tall you could build because you have the memory of that space. You have the memory of what that landscape was. Just how much, you know just how much brick that landscape can carry. What kinds of foundations you have to put to go in there. And if you're a planner, you know exactly why the roads are always so terrible, because a lot of them are resting on old seawalls, foundation seawalls that they had to build and then fill in order to put roads and buildings through there. And that's why they sink and they flood all the time. And if you're a historian, you know, and you could tell people why exactly you have this long core along that original road, and then all of the buildings drop down really quickly. Now, you look at that from outside of Boston, you think that's just charm, that's quaint old world charm. But if you understand the context of Boston, you understand the history of Boston, you have knowledge that allows you to see exactly what's going on here. You're seeing the experience of building in Boston, the experience of filling in that soil in order to create that land. But the folks at IMPay's office, despite the fact that they were world-class architects and engineers, they didn't see that. They didn't know it, they couldn't see it. So even though they knew, they knew their craft well, they didn't know the area well. They couldn't see that they were going to run into problems almost immediately with their brand new 50-story glass tower. Because they also looked down, and downtown, you know, there's a lot of tall buildings already, so they thought, Boston is a home to tall buildings. It just so happens that this is a conservative area of town, and maybe that's why. Maybe that's the knowledge that we're remembering. Maybe the fact that the people who lived here wanted a certain kind of life. Maybe that's the knowledge that they're visualizing there. So when the builders got started, you know, they started digging up this old landfill area. And they very, very quickly ran into a problem where the initial hole that they dug, in the ground, almost from day one, the walls started bowing in. And there's tons of photographs in the Boston Society of Architects library of all of the different schemes that they had in order to try to prop up those walls so that they didn't collapse in while they were trying to do the construction. So they ran into the water a lot sooner than they expected. This is a problem that people are dealing with in Manhattan at the Freedom Tower. They had the same problem there. The walls bulged, and the more they tried to pump the water out of that space, the more that the houses around it, which were brick, but they were floating on these floating foundations, they started to sink and they started to crack. And then the church, Trinity Church, you can see in this image, you can see this is what the square looked like before they started planning. Trinity Church started to settle as well. And Trinity Church's foundation was one of the worst affected. But they kept on building their tower, and they finished it in 1972. And it was beautiful. You can see in this bottom image, you can see the new tower with the older, much, much lower, it's about half the size tower in behind it. These are the two Hancock towers. And it was that signature on the landscape that Pei and his partners had been looking for. But almost from the very first minute, it was a catastrophe. Because when they finally took away the coffer walls, all of that water started settling back in, started rushing back in, and the building foundation started to just slightly shift. So, and I actually worked inside this building. My first job in architecture was on the 50th floor. Sorry? Well, it's worse than you think. So, they're never going to let me back into Boston. So it is worse. So as I said, when the water started coming back in, the foundation started shifting and the building started moving. So what you ended up with is inside those buildings, all of the walls shifted out of alignment. So you had doors that wouldn't close. You had doors that would pop open in the middle of it. Like you just walk by it and the doors would pop open. The building sways in the wind, so that on my floor where I was on the 50th floor, you could get quite seasick if it was a windy day. And for anyone who's really interested in the history and technology of tall buildings, you really want to study this building because they built what's called a mass dampener. This is why my lectures end up being really long as I digress. They built what's called a mass dampener, which was a massive lead block that they put on a field of oil, and they bungee corded it to the corners of the building. And as the building sways, it sways in the opposite direction. And it corrects the movement of the building so that eventually you have everything settling in, and it keeps everything in equilibrium. But the interior problems were bad enough, but those weren't the worst problem that they had. Pei's office was trying to be innovative in the way that they were wrapping this curtain wall. And so they created these new glass enclosures, these double pane glass enclosures, and they faced the entire building. They wanted it to be highly reflective. And so they faced the entire building with these glass panels. There we go. And since the building had a tendency to move, the squares within which those windows were supposed to fit, they weren't exactly tight anymore. And so what started to happen almost from day one is that the panels would just pop out in the middle of the day and go crashing down to the sidewalk. So that over time, what we ended up with is what the people at the Boston Globe would call the plywood skyscraper. They would replace each one of these panels over time with plywood as they popped off. And for a long time, I had a bottle on my desk that had glass pieces in it from one of these glasses that had fallen off of the building. I still have that. I should have brought it with me. And it also got to the point where if the wind would get to a certain speed, the Boston police would have to close the area down around because it was too dangerous to let people walk on the street because you just knew that at some point a panel was going to pop out. So they ended up, come on, here we go. There we go. So they ended up having to pay, seriously, over time they had to replace almost the entire skyscraper with plywood, and then they had to redesign glass for it and resheath it in glass while it was standing up. All of this because they didn't see the problem they were going to run into. They didn't remember, they didn't know that a building that size was not going to be possible to be on that block because they could clearly see that you could put a building that heavy 2 blocks away, 2 blocks closer, where the road was sitting on bedrock, where all the buildings were sitting on bedrock. And it wasn't because nobody knew this history. This history existed. The Boston Society of Architects wrote them a really amusing series of letters over the 5 or so years that they were working on this building, increasingly upset about what they were proposing. So the knowledge existed, but it was scattered into all kinds of different silos and disciplines. Despite the fact that there were world-class people working on it, something as simple as the memory of that landfill wasn't readily available, wasn't clear as day for them to see. And that was nothing. Things are way more complicated today. Cities are only getting more complicated as we go. There's a project at New York University where they're doing a lot of work on charting the growth of urbanism over time. Anyone who's interested in the growth of urbanization should take a look. But the history of city development is of greater complexity, of complexification. It is things getting more and more integrated, things getting more and more obviously denser, bigger, thicker. To the point where now Paris is considered a mega region. It's got 2.5, 2.5 million, roughly 2.5 million people living in there, and that doesn't include the tourists. So in August, that's probably twice the size. And that becomes significant because urbanization isn't going to stop. Urbanization is a train that is moving fast enough that we're not going to be able to shift it. And that's probably a good thing because over time we've grown to understand that urban areas are more sustainable. You have the density that enables a lot of services. You have the density that enables people to have new businesses, new ideas. It lets people live in a different way than rural life does. It accelerates everything, and it's a feedback loop. That's only going to keep increasing. And the other thing to keep in mind about this is it doesn't just count for people. When we think about urbanization and why urbanization is a challenge, we think about it in terms of how many people are around. But we forget that complexity happens more than just on a personal level, on an interpersonal level. We're also talking about 1.2 billion cars in the world right now, and that's slated to increase. 7 million drones. Everything from the little aerial drone that you use to, annoy your kid brother with, to test drones that they're using for packages, to the less salubrious kinds of drones that we're using to carry weapons around, to surveillance drones, all kinds. And again, these are only going to increase as everybody moves to try and capture more information. The easiest way to do that is to put another drone in the air. And 20 billion connected devices. 20 billion connected devices. And when people think about that, they think, oh, that's my phone, right? That's my phone. But keep in mind that most of the connected devices that are out there in the world and are going to be out there in the world are increasingly not even talking to you. They don't care about you. It's your washing machine talking to the factory to say, I need some maintenance. It's your refrigerator talking to the grocery store to say, have a drone send me some more milk. All of this kind of complexity increasingly is going to happen around us and without us being aware of it. But city planners don't have the luxury of not paying attention to that. They don't have the luxury of saying, I know that's happening, but it's not my problem, because it's increasingly going to be the problem to figure out how do you move those things around in the space? How do you understand how delivery vehicles are going to interact with rush hour traffic? How fixing potholes is going to be a problem because you're closing down more roads to give more priority to pedestrians, to cyclists. You're going to create new cycling tracks, and those are all great, but those are going to drive up traffic on the roads that are left behind. Those are going to create maintenance issues. All of these issues start becoming more and more complex as time goes on, and those complexity feedback loops are only going to increase. There's no turning back now. Is everyone scared yet? So complexification is happening in a context where there's no real way to turn it off. And it's happening in a physical environment where we have more than ever that we have to devote our attention to. So legacy infrastructure, new developments going up right next to old developments, more people, obviously, we've talked about this, more cars, more vehicles on the roads. And those are only the things that we see. We all aren't aware of the whole vast network of things that are underneath our feet everywhere you go. In Boston, we have a 100-plus-year-old transit network. We have your pipes. We have electricity that runs, all these services that run through the streets. All of that, as an urban planner, you don't have the luxury of not thinking about it because it's down there. And the moment you say, that's not my problem, I don't have to see that, that's out of my mind, something is going to break and your street's going to collapse from a leak. And we're facing other problems too. You know, we have rising pollution. We have garbage. We have increasingly climate-related changes, like fires, for example, and other weather effects, other geological effects like tsunamis. And over time, it starts feeling overwhelming, you know, especially when you're an urban planner and you have to think about, I need to take steps to plan around the reduction of garbage. I need to take steps that make neighborhoods safer so that when there's a fire, it doesn't spread all over the place. I have to be able to understand that I can evacuate people in the event of a disaster. And you start thinking about that and you quickly get overwhelmed because we still have this idea as designers, as planners, that all of the important work that gets done for the design of cities happens in your head. And the biggest thing that we need to do is to completely let that go. To completely let go of the idea that in order to be a good and effective planner, in order to make the future of cities, you have to pack your head with all of this knowledge. You have to know that the cow story isn't true, and you have to know the truth of the story. Don't think of a cow. So we have to get over the idea that all of that knowledge out there has to be held within our own heads. And still, we have to know that we're building with all of that in mind. And the way to deal with that is the same thing that's causing a lot of our problems. A lot of you have them sitting on your laps right now. Is the thing that we can turn to help us save ourselves. So this is a little polemic. So we need to virtualize. We need to understand that it's no longer enough to know things, to collect that knowledge, to make sure that the historians know the history of the Back Bay, to make sure that the planners know why the streets are so difficult to take care of in the Back Bay. We have to be able to capture and recognize that these streams of knowledge have to be collected. We have to capture them, and we have to capture them in a way that doesn't rely on fallible humans to communicate. Because if I'm in a classroom and I'm trying to tell you, if you're going to be building in the Back Bay, there are these things you have to know. But I can't always be there with you when you're sitting at your drafting board, so you have to be able to externalize that collection. We have to do what's called federating our data. We have to bring all the things together that we know into the same place. We have to pull that all together, because if you have to go to this library to understand tax data and who owns the land, and you have to go to that library to understand what the geological context is for a particular building, it makes it much more likely you're going to miss something, much more likely that you're going to forget something. You're not going to know something, so you're not going to be able to see it. You're not going to be able to see what the consequences are, where the interactions are. And the seeing is a really important step. We have to be able to visualize these challenges. There's a really, it's another digression. Somebody time me. There's a really cool thing about neurobiology, which is that there are two ways that information gets into our brains. We hear things and we see things. We hear the stories that we tell. When you listen, the information that comes into your head goes into your auditory cortex, and then it goes into the part of your brain that understands language. And that's great, but it takes like a few seconds for every fact that I spew out to register, to go all the way through your brain and to get locked in there. But when you see things, your visual cortex is directly linked to the knowledge and processing centers of your brain. When you see something, your brain gets it a little bit faster. And that's why the most potent technology that we have is the pencil. It's the ability to visualize. And you guys all know this because you're all visual arts students. You're all design students. You're all understanding fundamentally that the way you solve problems isn't just to pull a bunch of facts together. It's to turn those facts into something that we can see, that we can recognize, that we can share with others outside of our disciplines, because when you make them visual, they get into people's brains that much faster. And then finally, we have to remember that the most important thing about all of this material is that every choice that we make has to be focused on how it lets us collaborate, how it lets us work together. Because again, it's not important that historians know the facts on the ground and the geologists know the conditions underneath the ground. All of that has to come together, and people have to be linked and united in the same plane in order to be able to bring that knowledge together. And the important thing about this is it's a cycle. There's no stopping here. Each one of these steps is just a point in a spiral. You just always think that every time you think you're stopped, every time you've created a new knowledge, you have to also think about how to turn that back into something that can be captured by the system. There's no end. It's cradle to cradle, not cradle to grave. What's going on here? So when I'm talking about virtualizing, the most important first thing is, when I started out in architecture, we still did this. My very first desk was very much like this one on the corner, where we had big rolls of paper, and I had to draw on them. I actually drew on linen. It's really terrible. Beating off dinosaurs to get to work every day. So now we have workspaces that look like this. This is a friend of mine who works at Skidmore. So we all use computers. Like I said, most of you have them either in your pockets or on your laps right now, and that's great. It's really important that we have computers, but right now a lot of what we do is we think about using computers in the same way that we think about using pencils, in the same way that we think about using those rolls of paper. We think about them as two-dimensional capturing of space. They don't move. They're not active. They don't interact with other things. Maybe if you're lucky, you have vellum, and you can move them back and forth and trace over some paper, and you can see what's still underneath. And that's an insight that's really important for design students that the rest of the world doesn't get, the transparency of linking the different layers of information together. Now we talked we talked a little bit about GIS, and GIS is important. It's one of the biggest technological developments that came along to assist urban planners in doing their work, because the first thing it helps you do is collect all those layers and be able to sort through them. So you can gather information in one place. You can start looking at how the relationships are drawn together. And it's important to be able to see who owns the land, what's the zoning in an area that allows you to do something with that land. It allows you to start making problems visuals. It allows you to gather data in a way that lets you directly see what a problem is. Now, you guys probably know this better than I do, but we're starting to look at tax collections. There was a data set that was produced not too long ago, I think it was maybe 2 years ago, that came out of Detroit. They were looking at the mortgages in Detroit and how many were owned outright, how many were in foreclosure. And until you have technologies like GIS, you can't pull all that data together and make it visible in a way. All that data existed. Assessors had that data. It was just locked in spreadsheets somewhere. And until you can put it on a map and show how dire those conditions are, it's hard for people outside of the tax assessor's office to understand really what's going on. But once you could see diagrams like this, people started to understand just what a crisis the foreclosure, the incidence of foreclosure was. And not enough has happened with that, but people started thinking about that as a problem. It's important to know to have this assessor's information, because it allows you to look at who owns the land, to understand how that land is allocated, and then to start doing things like doing zoning analysis, where you can start thinking about, well, what's the current status of that land, and what do we want that to be? What have the planners decided is right for that? Now, maybe it's a single-story building right now, but maybe we want 4- and 5-story buildings in the future. So already you're starting to see one of the main failing points of GIS is that it mostly exists in 2 dimensions. It enables 3-dimensional work, but it's not inherently 3-dimensional information. And so you're already starting, when you're looking at these maps, to think about what happens when you extrapolate that information into 3-dimensional space, and you start doing things like zoning build-out studies. How much more density could we put into a space? And when you start thinking in 3 dimensions, you start collecting information and layering on other information that becomes really key and important. Like, for example, if you need to build more area in a city, what areas of that city are most likely to flood? Paris is struggling with this right now, where they haven't yet hit the 1910 average, but I think they hit 8 feet deep on the Seine in terms of flooding. They had to move paintings out of the Louvre. If we're going to build denser cities as we're going forward, we have to know not just where is it going, could there be a 100-year flood, but where could there be 100-year floods that are going to happen a lot more often now? And we can't leave that information locked in some silo in some office. We have to be able to see it when we start designing so that we can start to say, oh, I want to move the bulk of my building over to this area and I want to build differently here because I don't want the tower that I build to start sinking and causing cracking in the buildings around me. And we have to be able to understand the conditions of the city because we have to think about how we use utilities, how the energy, how much energy we use in order to operate our cities. We have to know, one topic that's connected to flooding is how much permeable space is there in a city. Anyone who's trying to figure it out, this is the city of Rennes in France, which is in Brittany, which is a city that I've been doing some work with. And one of the things that they're doing in this new image is that they're looking at the ground coverage and the heat produced by the ground coverage of the city. Because they're trying to move to a model where instead of having all of the city served by outside energy, they're going to look district by district in order to understand how the heating and cooling needs of that neighborhood can be accomplished by changing the surfaces of the ground, by changing the orientation of the buildings, by changing the way that those buildings are served. And they're starting to look on a building by building level at what kind of energy is needed to heat, cool, and illuminate that building. This is a different city. This is the city of Singapore. But one of the things that they're looking at in Singapore is they're trying to understand, because it's a hot, muggy climate, they're trying to understand how the wind that moves through the city can be used in order to help the buildings of the city be cooled, be made more comfortable without needing to add extra air conditioning, because one of the things that they're trying to do is do the exact same thing. They're moving to a district energy model where each district of the city is going to be served by energy that's connected within, that's generated within that city. So we're talking solar power, wind power. And they're also looking at ways to redesign the physical structure of the city so that it's cooled by the breezes that come through. And as I pointed out in the city of Rennes, they're looking at moving to a district energy model, and they're looking at building by building, how expensive is it in terms of energy to heat, to cool, to illuminate that building, and what can we do with that? And finally, the most important end piece that I was talking about is that collaboration model. So as was mentioned, I work for the city of Somerville. I volunteer, I serve for the city of Somerville on the planning board, and I don't know how many people recognize who this is. Oh, that's painful. Okay. So this is Robert Moses, and he is the epitome of what we in the planning field nowadays consider the bad old days of urban planning. And the reason that he's a representative of the bad old days is the model that he is representing here is one where the city planners decide what's going to be done, and then they announce what they're going to do, and then they deal with the public rising up to say, whoa, wait a minute. What do you mean you're going to build a 60-story tower in the Back Bay? Don't you know that's going to fall over? Don't you know that's going to damage my house? And we're still suffering in so many cities with the interactions that were produced when people weren't listening, when they decided that decisions could be made from above without being able to see the knowledge on the ground, but without being able to understand what was being done to the fabric of these neighborhoods, what was being lost in terms of local understanding, local knowledge when these gestures were made. One of the most important things, and we're back in France again, one of the most important things that we're going to learn how to do and need to use our technology to do is to help people understand what's coming in the future. I talked with one of you, I think, on the way here about how difficult it can be to get everybody to understand what new projects could benefit them. We talked about this a little bit in context of your library, that sometimes people even can understand that something will benefit them in the future. But because they can't quite understand it, we had this problem in Boston with the Big Dig. We all knew something good was coming. But man, it tore up the city for 10 years and everybody hated it until suddenly everybody didn't hate it anymore. So one of the biggest benefits of having these technologies, of having these technological tools to bring together all this information, is that you can turn information into an image of what the future could be like. So before you start proposing an actual building on this space, you get to understand what people are comfortable with. You can see a massing model, and you can meet with the public, and the public can say, no, 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 we're not happy with something that big. And you can have this negotiation. And somebody might say, hey, wait, do you know that there's landfill under there? Do you know that way back when the property owner did this thing, and that's going to affect the way you can build on this site? Until you can pull all that data together, make it visual so that you can share it with people who aren't trained to read a blueprint, who aren't trained to read a section, who don't know how to interpret the drawings, the particular kinds of visualizations we make. Until you can bring those people in, you can't get the knowledge that they have. You can't adequately collaborate and interact with them, and you can't know what's best for the city until you can understand how to build a space where everybody can come together, where instead of announcing what's going to happen, you dialogue with people, you collaborate with people, you invite people into the process, you learn from them, because it's not just about inviting them in earlier in the process so that you can tell them. It's also about like making space for them to share with you. Being generous enough to give somebody something in a form that they can read it and respond to it, so that the knowledge and the experience that they have can be made valuable. Because the thing that we as planners tend to forget so often is that just because we have the expertise doesn't mean we have all the knowledge. Cities are always going to be these difficult spaces, these complex, multi-layered things. And they're always going to be the most incredible technologies that we put together. They're always going to represent the most perfect technologies that we are able to build. And we have to figure ways of virtualizing the knowledge that we have of those cities so that we can share it more broadly, bringing it all together, and then collaborating on it so that we all build the future of our cities together. I'm delighted to take questions. Your questions are probably way more interesting than my talk.
So great presentation. I have so many questions, but I'll limit it to just two. So I can remember the Time magazine articles about the John Hancock building when I was in, I think, high school. So was there no site plan approval process? Because at some point, the city of Boston has to be informed by this. So is it a lot of payola, or, yeah, that local knowledge would have come in at plan review, right?
Well, so keep in mind that the 1970s, local knowledge was thought of as curiosity. It was one of the things that I did for some of my work, and it was a long time ago, was I was looking back at a lot of the planning board minutes, and the way that the planners, the city planners, and the design team interacted, like they're colleagues, right? I know what it's like to build a building, and you know what it's like to build a building, and that historian at the Boston Society of Architects, yes, she complains about everything because it's not brick. So we don't have to listen to her. You know, it's not expert knowledge. And because it wasn't expert knowledge, it was considered a niche thing. So it was easy in a way to devalue niche knowledge. When you can't see the implications of it, it's not as much of a slam dunk that the historian needs to be listened to.
I guess the soils engineering, though, is not like a flighty topic. But anyway, so that's fascinating.
We've made extreme leaps in soils engineering.
Yeah, right. So I guess the other question, I'll surrender the microphone, is I think this idea about layering information is really interesting. So are you also looking at layering information that's about other species, for instance, how urban spaces are encountering other living creatures and conflict, or sometimes how they coexist together well?
So it's a fascinating question. One of the pleasures that I've had is that I got to meet with the city planners from the city of Rennes, France. And like the folks in Singapore, they are really hyper-focused on the urban forest. So they're looking very carefully. In Singapore, for example, the city model that Dassault Systems built for the city of Singapore, each and every single one of the trees in the city has been geolocated, has been dated. They have a complex history for that tree. They understand where it is in its growth cycle, where it is in its overall life cycle, how healthy it is, because it matters so very much to them that they can have a streetscape that is comfortable. I mean, again, it's a tropical climate. It's an incredibly uncomfortable place to be in the middle of summer or in the middle of the monsoon season. So the vegetation takes on this importance that, you know, in a place where we have tons of trees and we don't really think about those trees, it's, I would say the will is there, the ability is there. It's like the will to consider different elements then comes in. But I mean, when you start looking at platform approaches to the making of cities, you're limited only by your willingness to consider visualization. So however you start to take in data and virtualize that data, if that happens to be migratory bird patterns, if it happens to be, we're having great trouble in Boston with turkeys and with coyotes coming into the city. So people are geotagging the turkeys and the coyotes because, you know, even though a turkey crossing the road is causing an enormous backup, people are really protective of the turkey. They have a Twitter account, the turkeys. But really, when you start to think of a city as a platform of layers that can be stacked, you're limited only by your willingness to capture the data and virtualize it.
I think June, you had a question.
Do I have to use it?
It's for our online.
I think I just...
Okay. So in Detroit, maybe I sit down, I'm sorry. In Detroit, there are maybe 205 neighborhoods in Detroit. There may be a couple hundred community-based development organizations. One of their challenges is a lack of access to data, or limited access to data. If you could say a few words about, if you could say a little bit about how you could make it easier for these advanced groups to access the data, or perhaps how about the idea of democratizing data access or data acquisition? Maybe you could say a few words about it.
You put your finger right on what I was going to start by saying. So I would say two things. The first thing is anybody who's in this room listening to me wants to leave immediately and go to your own local resources, which is Maurice Cox, who is a planner. I think he's the director of the planning department. And he is an enormously intelligent, enormously creative, truly brilliant man. And all of you who are interested in the health of the city of Detroit itself, as well as the future development of urbanism, need to be paying very close attention to what he's doing, because he's accomplishing enormous, enormous gains with incredibly modest inputs. The part of the way that he has gotten a lot of the work that he's done accomplished is that he does exactly that. He democratizes data. He goes out with his planners into the city, and his planners are the only thing that I can possibly say against Maurice Cox is he keeps trying to hire away one of our planners in the city of Somerville, and it makes me very angry because I want to keep him. But he hires great people, and then he takes those people into the communities, and he gets them listening. They're collecting, what do you know is important about your neighborhood? And in some cases, that's this grocery store actually collects mail for people who can't safely accept mail at their house. in this location, there's a, I'm forgetting their name, there's a design practice in Dearborn that's doing a lot of work collecting different kinds of data. So they were looking at things like cigarette sales, what brands were most popular in different neighborhoods, and they were trying to try to map all the different data sets that you could get. Because when we start thinking about data, we start thinking about like the American Communities Survey, we start thinking about the decennial census, we think about the big data sources. And one of the problems, this goes back to the thing we were just talking about, is one of the problems is you think about those are the only validated data sets. So those are the only useful and important data sets. But once you start thinking about cities as just open collectors, you start thinking about, well why aren't the location of trash receptacles valid data? Like, what if we mapped every single trash receptacle in the city? What does that tell us? Who knows? Let's do it and figure it out. Once you start opening up the idea of a city as something that, it's not that something that the planners give to you, it's a space where planners and community members come together, you start realizing that there's so many more data sets out there, and as a planner, I may not even know what the most important data set there. I have to go to the community to find that out. I may go to the community and say, the most important thing I can tell you is that you are going to get a new middle school. And they'll be like, but no, you need to pay attention to the dog parks. The dog parks are what's key here. So really, again, it comes down to getting rid of the disciplinary boundaries and thinking of data sets in different ways, so that whenever you gather 3 points of information, that becomes data, and you start thinking about, well, how now do I virtualize that? How do I make that visible? What choices do I need to make in order to show that to other people, so that now you and I have created a set of representations of data, and maybe somebody over here looks at that and says, hey, wait a minute, now that I can see that, I know that that has relevance for me, and I can make decisions based on that. Answer your question?
All right, so I have about 8 different questions, but my favorite one is, you mentioned like the system of a city, and like how certain environmental impacts kind of control and dictate what happen in it. How are you finding trying to control that system that seems to misbehave and fight back? And like, what's the most compelling truth you're learning from it?
I would say the most compelling truth that you learn is you don't control it. You have to respond to it. Moses made the mistake of trying to control everything. And as a result, he broke the city. Moses drove expressways through neighborhoods, and he broke the city because he wasn't listening. He was dictating to it. I would say that as a planner, the most important thing that I have learned in my attitude toward the city as a system is that the city as a system is bigger than I am. And I have successful interactions with that system in direct proportion to the degree to which I understand it's not under my control. I can nudge. I can't steer it, but I can nudge it. You can make small changes, and the small changes ramify. But by trying to shove, you only break.
Oh, thank you.
So other than fighting off dinosaurs, I was interested in what new advancements in technology are preparing infrastructure to keep up with the rapid growth in urbanization.
I missed the last little bit of it.
What are the new advancements in technology that are preparing infrastructure to keep up with the rapid growth in urbanization?
Well, do you guys do much coursework on BIM modeling? So it's a bias of mine. It's a trend that you should look into. Building information modeling, BIM. And it's a new way of thinking about the production of architectural documents, infrastructural documents, where instead of, where instead of looking at a conceptual model of a building, you know in your head what you want to build, of a bridge, a building. And then you have to think about, well, what does it look like if I cut it off 3 feet from the ground to make a plan? What does it look like if I cut it right here through the building and do 2 sections? What does it look like from the front facade? What does it look like from the back facade? What do you get if you do the reflected ceiling plan? Instead of thinking of the design process as being captured by these images that we make of this thing that exists in our head, we build it directly. We build a digital twin. We build a virtual model of the thing out in the world. And most importantly, we build it in geolocated space. So it's, you know, the way you guys all have on your drafting tables cardboard models, just build digital models. And all of the information about those structures, buildings, bridges, you name it, anything, comes along with data. It comes along with semantics. It says, you need this many, thousands of tons of concrete in these different shapes and assembled this way, and there's 18 million joints, and there's 2 billion bolts, and each one of those bolts you can drill through and you can see in space. And it's, again, it's this thinking of you bring all of that data into a space. You virtualize it. So instead of a chart, a table of all the bolts, you have a physical model, well, virtual model, and all of those bolts are distributed across that model so that when you want to figure out which one you want to look at, you go straight to it. And then the best thing about that is, unlike the model on your drafting table, it's not done when you stop cutting the cardboard. You step away from it and you give it behavior, and then you can say, oh, well, what happens? You guys are all familiar with the Tacoma Narrows Bridge? The bridge was a bridge that fell down because it started to get that resonance in it. What happens if you hit it from winds from this to your bridge, if you hit it from winds to this direction? You watch it do it. Because the model is sort of real in a way, you watch it behave. You can put it to 200 years of growth in the computer, because the computer's brain is faster than yours, and it can do all that heavy lifting for you. You think, what do I need to ask? And you let the computer do the work for you. So if I could tell you guys to do one thing, master one thing before you start looking for jobs, get into building information modeling, understand what benefits that can provide, understand how that is going to revolutionize the future of how we make everything, buildings, cities, you name it, everything from start to finish. The ability to virtualize the physical structures and the processes that are affected by those, that are applied to those physical structures, that's the future. Full stop.
There's more questions. I'll be lazy and go to Peter first and then to Sandy.
I'm thinking of the big tunnel project in Chicago where they, built this gigantic tunnel to handle the stormwater of the city, and by the time they finished it, it was too small. And so it makes me think about building codes and building regulations, and instead of the pace at which codes are changed or adapted to whatever the conditions might be. Can you talk about just this? It seems to me that if you had things linked enough, the code would constantly be changing. I mean, in terms of how one had to handle, like, impervious surface on a site or something. We might look at a building regulation that was established 10 years ago or something, and it's, of course, just blown out of the water. And further complicated by climate change. So anyways, can you talk about that?
I certainly can, and I don't have the Wi-Fi password, so unfortunately I don't have visuals for this. But in the city of Somerville right now, one of the things that we're doing is we're redeveloping our zoning code, and this is why I am desperate to keep Maurice Cox from poaching our planners. Because we are moving away from, if you picture the typical source code for the planning of a city, it's legal language. It's whereas we have understood X, therefore Y will be what we do. And it's written by lawyers, and no offense to lawyers, what do you say? Like, some of my best friends are lawyers. The problem is lawyers have this habit of talking pretty much to each other, as opposed to all of the rest of us. So all of that language is sort of static. It captures, it tries to literally stop everything. We're moving to a more form-based code and to a use-agnostic code, where we start talking about the performance of systems in a city. We start talking about how much traffic we would like along certain corridors in the city, and how we set up a series of criteria for either inhibiting or promoting growth in those areas. And then once you have that as a mental framework, you're no longer trying to sort of pin down every possible thing that could happen and decide on a minute, moment-to-moment basis, do we allow a sign here? Do we not allow a sign here? What kind of sign do we allow here? Do we allow lighted signs? No lighted signs. You talk about general rules. The code becomes algorithmic. So that if you change the inputs, you no longer have to go through 600 pages, and I kid you not, 600 pages, it's like that thick, of zoning language in order to say, well, now every time we talk about sign in this code, I have to make sure I flag each one of those things. You just change the behavior. You change one element of a behavior. And that ramifies. It just sort of distributes out like ripples, basically. But it comes back to the idea that you let go, and this is hard for the people of the city of Somerville. This is why I get screamed at on a regular basis. It's hard for people to think their way through the idea that we can have better cities if we stop trying so hard to make them a particular way, and we just set little rules, little behavioral decisions, and then sort of let them go, see what happens. And if they start veering off course, then we change a set of parameters and constrain behavior that way, as opposed to chasing after it each step of the way. I don't think I'm answering your question, but I think that's the way we're thinking about how to address that problem. I don't know if you want to follow up on that, but that's where we're going.
Okay. Thank you.
Sure.
Two more questions. Sandy and then Otter.
What you just said just kind of tied into my question. I was going to ask you, how much data and responses can you collect from the community until you have to draw the line and realize that budget, design, timeline, they're all at stake? Like, because you can collect it for so long until you have to actually implement what you had in mind.
That's an enormously important question. It's not just a great question, it's a very important question. I'm going to cop out of that one, which is that as a planner, a lot of my bias, I don't write the checks, and I don't have to go, I'm not elected, I don't have to go out and say, in order to build a new school, we have to raise your taxes 5%. That's not my responsibility, which is a relief, because my professional response to that is that there's no limit. There ought to be no limit, because the more layers of data we take in, the better our decisions can be. The more understanding we can gather, the more informed our processes can be, and that's only to the good. I mean, whatever. Neil Dash said something really profound the other day. He has a TED Talk, I think. I was listening to it in my ear, and he said something is, one of the problems that we have as Americans is that we think technology is going to solve all of our problems for us. Now, technology is powerful, and we have achieved a place in society where doing without our technology is unthinkable. And certainly, without the technological support, we won't achieve the goals that we've set for ourselves. But the technology doesn't solve the problems. We have to, amongst ourselves, decide, what do we value? Now we can and we ought to collect as much data as we can get our hands on, of all sorts. There was a really great article in The Guardian Cities that I can't get out of my head, which is there's a new metric that people are talking about, and it's called the popsicle metric. And it's literally an accidental discovery that some planners made when they were collecting data, and it's a way of tracking how far you can walk as a young child by yourself, unaccompanied, to get a popsicle, buy that popsicle and walk home with it before it melts. And they were, the planner who was looking at this, and it's in the Guardian Cities, I think it's part of a research set that's been done under the support by the Rockefeller Foundation. But it's those kinds of things, like we don't know what data is going to become important. We don't know what new technique for visualizing how to move through the city is going to come up when some creative person that everybody thinks is a dingbat is sitting over in the corner and just says, well, what if? What if, right? The other side of that is more difficult. Then we have to make really hard choices. You know, sometimes you can't put a sidewalk everywhere. Sometimes you can't have crosswalks the way you want them. You have to make those decisions about how you're going to spend your money. But those are human decisions, right? The technology can do everything else so that we can then spend the time to make the human decisions.
Thank you for a thoughtful presentation. I think talking about technology using applications like GIS or connecting to some of the perceptions and neurobiology like space syntax or urban network analysis from Boston. I mean, it's a lot of layers and heavy on analysis. I wanted to know, do you think how some of these new technology and integration, do you see new opportunities of these to be directly generative?
When I was at Harvard, I took classes with somebody who has spent most of his career trying to absolve human beings of the responsibility. So in the 1960s, everybody got really fired up about design, and then in the 1970s, the bottom fell out of the market. And a lot of architects were like out of work. And so you had a lot of people doing these paper projects, thinking like, when people pay attention to the role of architects in society, and urban planners especially, of how the decisions we make have effects for income inequality, how they have effect for social justice, how they affect the rights of the city, how they affect whether or not a city affords basic decency to all of its residents equally, regardless of any status about them. That can be an uncomfortable position to be in, and I've been in public meetings where we're trying to do the best we can, and people are justifiably upset about, you know, the cost of real estate in the city of Boston. And there are a lot of people who are looking at ways of absolving design responsibility by looking at algorithms. I don't just think it's a mistake, I think it's fundamentally wrong-headed, because algorithms are manifestations of our design intention. And the idea that we can like take our, like, give it all of our responsibility and take our eye off that ball is terrifying to me, because all of the important stuff about how we are going to create spaces to live, to move into the future together, fundamentally have to be decisions and discussions about our values, about what is important to us. Now, that's not to say we can't use algorithms to generate opportunities and options for us. I mean, you know, the iterative design process is one of the most important things you learn in the studio setting. You know, don't fail fast, fail multiple times, create 20, 30, 50, 100 versions of whatever it is you're going to do. And that's another thing that computers can do for us. We can give it rules and let it go. But I think that we should always keep in mind that no matter how many different iterations of some idea we can let the computer spin off, it always comes back to using the computer to support interactions and collaboration around what we value, what's most important to us, how we dream the future that we want to live in.
Thank you.
That's a great way to end it tonight. I want to thank you for joining us. I want to thank Dassault for bringing you here and allowing us to have these conversations and be talking about these things. So thank you again.
It was in every way my pleasure.